Welcome from the U.S. Fish and Wildlife Service's National Conservation Training Center in Shepherdstown, West Virginia. My name is Katie Poston, and I would like to welcome you to our webinar series held in partnership with the U.S. Geological Survey's National Climate Adaptation Science Center. And today's webinar is titled, Using Decision Tools to Design the Everglades Headwaters National Wildlife Refuge. And we're excited to have Stephanie Romagnac with us today. And to introduce our presenter today, we have Ryan Boyles, who is the Southeast Climate Adaptation Science Center's Deputy Director. Welcome, Ryan.
Thank you, Katie. And very pleased to introduce to you Dr. Stephanie Romagnac. She's a research ecologist with USGS. She's based in Fort Lauderdale with the Wetland and Aquatic Research Center. She's done a lot of work in Central and South Florida, working with Everglades restoration, and she leads a fairly large research program working with decision makers on a lot of the complex problems that they're dealing with in terms of how restoration funding should be allocated. She uses a combination of field observations, ecological models to look at impacts and connect that back into decision making. And that's one of the things, while this specific project that she's talking about was funded several years ago, it fits very well with the theme of this webinar series around the science that you can use. She brings decision analytics in and decision science in combination with the ecological models and the field observations that she collects. She's done a lot of work in Everglades in Central and South Florida, but also has prior experience working in Africa around conservation issues there. Thank you to Stephanie for coming back to talk about something that she probably hasn't thought a lot about in the past year, but I think the topic certainly still resonates with us today, especially the process that you went through to look at the reserve design for Everglades Headwaters. So with that, we'll turn it over to Stephanie and say thanks to everyone for joining. I hope you get a lot out of this.
Thank you, Ryan, and thank you, Katie. That is a nice setup to say that, yes, this project was funded some time ago. It was completed in 2015, but we only published the work maybe a year or two ago, year and a half ago maybe, but it doesn't make it any less relevant. And this was also one of my favorite projects to work on. So it'll be fun to talk about it again. And my apology will be if you ask me a detail that I just can't recall, because the technical details, it definitely has been a while. But like I said, it's just as relevant today, and the work by the Fish and Wildlife Service is ongoing. So as Ryan and Katie said, I'm going to be talking about the work that Fred Johnson, and I did to help the Fish and Wildlife Service with designing the new Everglades Headwaters National Wildlife Refuge. So designing a wildlife refuge is not too dissimilar from buying a house in some ways, although that might seem odd to say. Yes, it is a little more computationally complex, but the process in a way is similar to buying a house or any other big decisions that you would make. And so I would guess that if you're buying a house, you don't just get on Zillow and put an offer on the first house that pops up in your search. You would probably think about things that you care about, quality of life in general, but you'd probably be thinking about the quality of the schools your kids might go to, or the layout of the house, or the size of the house, or traffic patterns, or whatever it would be. You think about what you really want first, and then you'd find a house that matches those objectives that you have. And so if you're designing a wildlife refuge, chances are, just like if you went into Zillow and put in an offer on the first house you found, if a wildlife refuge manager just puts an offer on whatever's the first parcel of land that comes up for sale in the area, chances are that that's not going to work out too well. So the refuge manager will have to consider his or her objectives for the refuge when deciding which parcels of land to buy. So I'll get back to all those details about objectives and that in a minute. I'm getting used to the slide changer. So I'll tell you a little bit about reserve design in general first, and about the refuge, and then we'll get into more details. And so I realize that we are talking about a refuge, and I'm calling this reserve design, and that's because that's the field of study, is generally called reserve design. And it deals with identifying parcels of land that are in need of protection for whatever reason, to protect particular wildlife species or populations or habitats of interest, ecosystem functions, or whatever it might be. And that's done in another sense, just like buying a house where it's secured on an open market. You do this through a purchase. Some land can be put into easement, but there are challenges. Usually funding is not available up front to buy all the land necessary for an entire refuge or any other kind of protected area. And so what that means is that results in incremental implementation of that refuge or other kind of protected area. And what that leads to is, because we have to do this incrementally, it means that these purchases are made over many years, and in many cases made over many decades. And that subjects the area to changing conditions. So you might have properties that are lost to residential or commercial development. You don't know if you're going to have funding in 10 years from now in this case of the Fish and Wildlife Service, what is Congress going to authorize? What are the funds going to be in 10 years from now, or even next year? We just don't know. And then, just like with any real estate transaction, what's the probability of a successful purchase or successful land transaction? And as we know, there is a lot of environmental change, and so we had no idea what a particular parcel might look like, depending on management or nature or other factors. And so things could change. Whatever we think might make a good refuge now, that might be quite different in 10 years from now. So Everglades, so just getting into the study area a little bit. If you have worked in the Everglades or you're familiar with the Everglades at all, chances are you have seen this figure a million times or something like it. And so if you look over at the left panel, this is what the Everglades, and when I say Everglades, Everglades National Park is down here, but this is the Greater Everglades. And so this is typically, when we're in the Everglades, this is what we're talking about when we say the Everglades. And so this figure is what the Everglades looked like in the 1800s. So we had this area was the headwaters of the Everglades, and I'll show you that more closely. That basically formed this really nice sheet flow that moved south over the landscape. And then humans came in and started all of these lines here. Basically, people started digging, so they were draining this ecosystem. And these lines are levees and canals and other features that basically move water away for flood control, or in this case, agriculture, or whatever human purposes were. And so the system looks very different today than it did in the 1800s. And the idea is that we would like, with restoration, which will take many decades, we would like water to come from this headwaters and move south through the ecosystem once again. So why is this area important? This is the area that we're going to be focusing in on, and this is the headwaters of the Everglades. And it's important because in terms of the Fish and Wildlife Service desiring to have a refuge in this location, it's the headwaters of the Everglades. This can help to restore the wetlands and uplands in this region, some of which are degraded from human activity. And so there's a lot of restoration going on in that area. And this area in particular can protect a number of federally listed threatened and endangered species, 38 specifically, and 161 state-listed species. And it also connects habitats, which you'll see in a map that I'll show you of the refuge study area, connects them to other protected areas in the region. And so some are state parks or military lands that are under one sort of protection or another. And another idea was that this would be a potential refuge for many species from impacts of climate change. So zooming in a little bit, maybe I can reorient you. So here was Lake Okeechobee. This was the Kissimmee River coming down. So this is the headwaters of the Everglades. And then this, so here's the edge of Lake Okeechobee here, just to reorient you here. And so this is the Everglades headwaters. In black is bounding the study area, which is a 1.8 million acre area. And the reserve will not be contiguous. And so what this means is the Fish and Wildlife Service can select parcels of land from within this study area. And there are two constraints. One is that they can buy up to 50,000 acres outright, and then they can put easements on another 100,000 acres. So it'll be a 150,000 acre refuge when it's done. And the good news is that there are willing sellers. This was not the case at the start. There was a little bit of a turbulent start along the lines of the government coming in to take over people's property, but that has subsided, and so there are willing sellers now, and so that's not a problem. Some of the desired outcomes for the Fish and Wildlife Service in the conservation partnership area, and again, that's where the easements can be, are to basically keep working lands working. So allow ranching activities to persist in private ownership. You know, again, if they're reflecting the goals of the refuge, which are things like wildlife viewing, hunting, fishing. And then for the conservation focal area, which is where the lands will be purchased, some of the desired outcomes there are to have habitat for the threatened and endangered species and land to keep common species common. And they have an emphasis on migratory birds, listed species, and wetlands in particular. So the Fish and Wildlife Service had thought through what were their priorities. And so these were some of their top priorities, which were for land acquisition. And that was to have landscape connectivity or corridors through the habitats in the region, again, habitats for threatened and endangered species, and restoration of wetlands and water quality was very important, and you can hear that in the name of the Everglades Headwaters. And they wanted opportunities for wildlife-dependent recreation and educational opportunities. So some of the species of particular interest are the panther. You've probably heard about the Florida grasshopper sparrow. I know at one point it was considered the most endangered bird in North America. Things have not got any better for it. So unless another species has got worse, this one's was considered to be the most endangered in North America. And so there are a number of other birds and mammals and some habitats in need of protection, Florida dry prairie, scrub habitat, and sandhill. And so the Fish and Wildlife Service was looking at land protection options in order. And so the ideal would be if others would protect the land so that, you know, they wouldn't have to buy it or use the resources in those particular areas. The second option would be easements. And then the third, then they would go to a fee title or, you know, buying land outright. And that would, the focus there would really be for things like if they wanted to build boardwalks or whatever other kind of visitor use type areas that really wouldn't be as suitable to land with an easement. Okay, so just a little bit about costs. So it's not cheap to design and to pay for a refuge. And so if we look at the conservation focal area, which is where the land is going to be bought outright, the estimated cost is about $4,000 per acre. And so for the 50,000 acres that they can buy, minus some expected donations, it's just under 200 million. And if we look at the easements, that's estimated to be at about 2,000 per acre times 100,000. That's another 2 million. So just for the land is just under $400 million, plus some operations costs, both one-time and annual costs. So just to buy the land necessary for the refuge is about $398 million. And so you can see why I was saying that we usually don't have that kind of money all at once to just say, okay, here's the best design for the refuge, we're going to buy all these lands. It's just not going to happen. Okay, so the Fish and Wildlife Service did all of the hard work for us. So it can be really challenging to really get at objectives, and then quantifying them is another challenge. But the Fish and Wildlife Service did this quite nicely. And so they were very clear on exactly how many acres of each habitat they wanted. So, for example, 34,000 acres of wetland for particular species of interest, 13,000 acres of dry prairie. And so we had their objectives to work with while we were working on this refuge design. And so we ended up choosing to work with Marxan with zones. It's basically a special, Marxan with zones is basically what it allowed us to do. It goes a little bit beyond Marxan to help us find an optimal reserve design. It helped us to be able to consider what we considered as zones were easement and fee title. So we were able to allocate land in those two categories to help us meet the overall habitat objectives. And so Marxan was originally designed in the marine world in Australia. I think it was University of Queensland. And it's been widely used all over the world on land terrestrial uses as well as marine at this point. It's been in use for quite some time, and it's a pretty strong program. And so we used that because for me, I can't do trade-offs of calculating 50,000 parcels in my head. So we had to find some way to do it, and Marxan with zones was a great way for us to be able to do that. We were also able to look at the target habitat within a parcel, so not just the whole parcel, but making sure that we were able to get the habitat within a parcel while we did these analyses. We also looked at 2 urbanization scenarios, and those urbanization scenarios went out to 2060. I'll talk a little bit more about those later. And what Marxan does is it allows us to have a static solution to the problem. So this assumes we have that 400 million today, and we don't. And so I'll talk about that a little bit later. But this was the best we could do for this case. There are a number of other methods that allow us to look a little bit more dynamically, but not for 50,000 parcels. That method did not exist. So I'll just show you the inputs that we use, which is pretty simple and straightforward. These were the 5 inputs we used, which were the parcel boundaries and cost, habitat. So if you remember this, or I don't even remember if I said this was funded in 2012, and so that's where the numbers, you'll see these years of these data layers come from that time period. So we did the work from 2012 to 2015. So the parcel boundaries, the costs, and the cost we used was just value. The land cover, existing protected areas. I think I forgot to point this out to you on the map, areas not considered. The Fish and Wildlife Service, there were particular parcels of land that they knew they would not buy or put easements on, and so those they had designated as areas not considered. And so we factored that in to make sure we weren't selecting parcels in that area. And then, of course, we used the focal area boundary where we could buy land, and then we can't buy land outside of that, and so easements on the partnership area. So this is where we ended up. We had 4 counties, and to start, we had 200,000 parcels. We removed those in the areas not considered, removed those that are already protected, and we ended up with 51,000, almost 52,000 parcels to consider in the reserve design. So the 2 urbanization layers that we used have a lot of the same assumptions, but there are some differences. So there was one layer developed by a group called Geodesign for anyone who's worked with Mike Flaxman. He used to be at MIT. He's done a lot of work for Fish and Wildlife Service in the past. So he did a layer for us, and it used a 70-year median growth rate. He incorporated some local county regulations, and he develops an attractiveness index to look at where development, residential development might be occurring in the future. We also used a University of Florida urbanization layer. It had a lot of the same assumptions. It also used distance from existing development, development based on projected population growth, and major roads that are planned. So we ended up with 9 scenarios. So we basically had a current, assuming no further urbanization scenario, the geodesign scenario and the University of Florida scenario, and then we had 3 land allocation scenarios. So if we had 10% of land in the fee zone and 90% in easement, 33% in the fee zone, 67% in easement, and then 50-50 split. We also looked at connectivity. So we explored a range of values for the boundary length modifier or the boundary cost matrix, and it really had no influence, which suggested that our design was as kind of compact and efficient as it could be. And just so you're aware, and maybe I should have said this at the start, but I'm not going to show you a map of our final design. I'll show you plenty of other results, but I'm not going to show you that just because of the sensitivities of land acquisition. So you won't see a final map, but you'll see some other graphs and tables and maps of other parts that went into the design. And this, I just had to put up here the calibration because I thought it was quite crazy. So as Ryan mentioned at the introduction, I run a team, ecological modeling team, and I've just never, Marxan was new to me. That's why Fred and I brought in Brad Stith, who'd worked quite a bit with Marxan, and I just never seen 100 trillion iterations per repetition before, and I thought that was pretty neat. So I just thought I'd bring that up. It was a little crazy. So I will jump into some of the results, and I'll first show you the urbanization results. So let's see. So habitat, so this is the study area again. The gray are the areas that are existing protected areas. These polygons in the dark outline are areas where purchases can be made, and then the rest of this area is where the easements can be made. And so green is showing you habitat that is projected to not become urbanized by 2060. This orange is showing the habitat that the University of Florida model is showing to be urbanized. The purple is where the geodesign layer is showing to be urbanized, and then red is where they both are showing. And so there's most agreement between the two models up here in the Northeast. And we used 2 because we just wanted a broader look. I mean, like I said, they do have a lot of the same assumptions, but they have differences. And so we just wanted to be able to see what are these different approaches, what might they be telling us about where we might want to focus attention or not. That's another conversation and something I'll bring up later. So the good news is that the majority of habitats, you can see a lot of green, the majority of them are not forecast to be developed by 2060, so there'll be a lot to choose from. We did see greater habitat loss with the geodesign model, so the purple compared to the orange. So 31% habitat loss overall with the geodesign model compared to 20% for the University of Florida model. And then this scrub and sandhill, these xeric habitats had the largest projected losses from 40 to 60%, which is quite big. So let me orient you on this figure a little bit. There's a lot of information here. So here on the y-axis, you see area in hectares, and here are the habitats we considered. And what this is showing you is in the fee zones, if we look at just the area where we might make purchases, if we wanted 50% of the refuge to be in the fee area versus 33% or 10%, and this is showing you 100% just for reference. This really, this should be kind of a bar across the top to show you this is the target. That's what we're aiming for. But because that target is different for each habitat type, it's just represented here as another bar. But that way you can see what we were shooting for. These show the future scenarios. So in this case, current urbanization versus the University of Florida versus the geoadaptive. And really the bottom line here is that we were able to design a refuge that met the Fish and Wildlife Service objectives for all of the habitat types in all of the scenarios except for xeric. And this is the one that we had the most trouble with. And I'll show you an image here to give you an idea. So this is in our modeling world on the left, and on the right is a satellite image just to show you. You can see all these tiny little blue parcels, and this is what we had to work with for xeric. And so there was a point where we met with the Fish and Wildlife Service to talk about the outputs kind of as we were partway through the process and refining what we were doing to help. And we had made the decision that we weren't going to consider any parcels that were under 100 acres. And what that meant was all of these little parcels that have xeric habitat couldn't be considered. And so that's something that, as the Fish and Wildlife Service is moving forward with the refuge design, that they'll need to think about whether that 100,000 acre cutoff is across the board a good idea. And for a lot of reasons it is. I mean, this would be really difficult habitat to manage, but just to show you the struggle that we were having with that xeric habitat. And most of the area where the xeric habitat is already heavily urbanized, so it just makes it a real challenge. So this is similar to the other figure that I showed you, same setup. So 50%, trying to get 50% of dry prairie in the easement zone versus 67% versus 90%. And this is just in the easement zone. Again, we really only struggled to get the right amount of xeric habitat. Just to show you a little bit about cost. This is kind of obvious. Well, let me tell you what you're looking at before I tell you how obvious it is. So here's the cost on the y-axis. This set of columns is showing the scenario where we would buy outright 10% of the land and then have easements on 90%. And then we move up to a 33-67 split and then 50-50. So the more land that we're buying outright, so 10% versus 33 versus 50, as that amount we buy goes up, it's going to cost more money compared to an easement, and then shows us with the current urbanization, so if no further urbanization versus the UF model versus the geoadaptive model. And we always had a higher cost with the habitat that was projected to be left as available with using the geoadaptive model. And so we'd have to do a lot more digging into those models and understand all of the assumptions that go into the model and those projections to see why it's coming up that way. And again, this is why we use two, just to get a little bit of a broader look at a couple of possibilities of how things might play out in the future. In terms of the design, here again we have area on the y-axis. The limit for the reserve, if you remember, it was 50,000 acres in the fee simple and 100,000 acres in easement, and so that is 60,000 hectares, which is kind of up here. And so you can see in every way that we configured it, we were able to get the reserve to be smaller than what the refuge was aiming for. And so that's good news, right? Because we're able to meet the habitat targets that they have in a smaller area, which means you would spend less money on it. So that could be a really good thing if we're able to meet those objectives for the species and habitats, recreational and all those other objectives that they have. And we were able to do that in every scenario. Again, this was the splits of 10% fee, 90% easement. under the current conditions, what's predicted with geoadaptive and the University of Florida projections. And so no matter how you slice it, we were able to meet the habitat objectives well below the limit that the Fish and Wildlife Service has authorized. And this is something I want to show you just because I like it. This is a selection frequency that comes out of the Marxan output. And one way that I like to look at this is as a measure of irreplaceability. And so when there are parcels that are coming up over and over again, you know, in every design, every scenario coming up all the time, these darker parcels, that probably tells you something that these should be high priority areas when they do come available for purchase. So that's a really nice output we got, and that was something that the Fish and Wildlife Service really liked as well. So I mentioned that our approach was a static one. We did this design assuming that we have $400 million today, and we don't. And so Fred Johnson, one of my collaborators, ended up bringing in a postdoc while we were doing this work, who was a mathematician. His name is Matthew Bono, and he was tasked with figuring out a dynamic approach. And just for entertainment value, I should have put some of his equations up. Well, you can look at the paper and see for yourself, but it's quite something. I could usually follow him through 75% of what he was saying, and then he would lose me. It's pretty intense, but he was able to pull this off, even with the amount of parcels that we were looking at. And so this paper was published last year in PLOS One. If anyone's interested, you can look it up. And so we know that parcels are subjected to all these threats that we talked about earlier, like urban development, habitat degradation, climate change. And so he was able to come up with a way that accounts for the conversion rate of these habitats through time. And it's done on an annual time period, so it gets at that dynamic aspect that I was talking about. And you can see this trade-off of buying parcels that have high ecological value and the highly threatened parcels, threatened, to change, accounting for the conversion from one of these other factors. And so it's really neat that he was able to do that. And even if he finished this after, it took a while for him to develop this, and he finished it after the project had ended. But even if he had finished it during the lifespan of the project, we still would have needed that information to go into, we would have needed the information on, even if it's expert opinion or, best judgment on probabilities of those changes of habitat degradation and climate change, those conversion rates. And so that would have taken more time and another step. And I'd be interested to know if this method has been used since Matthew was able to put it out in the literature. I don't know. It'd be really neat. So just to summarize some of the kind of takeaways for us in working with the Fish and Wildlife Service on this, things that were really valuable were, again, we were able to get those designs well below the limit that they have authorized. And we were also able to get the cost down. So compared to the 400 million that was estimated, our maximum cost was 138 million. But I will note again that we are using just value. So there are problems with that type of database where someone can record the value of their, several 100-acre ranch at $1 to sell to their cousin or whatever it might be. And so the values might not be great, but this was all we could find in the records. And so if we had more accurate values for the land than for the parcels, then that would help us to know, are we really getting closer to this 400 million, or how much closer would we be getting to that? Again, I mentioned the selection frequency, which the Fish and Wildlife Service really liked in thinking about how to prioritize land as it's coming available. As I said, they're going to have to think about what to do for the xeric habitats where they're smaller in urbanized areas. How do you manage that? You know, can you burn those habitats with all those houses around? I mean, there's so much to think about for that xeric, meeting the xeric targets that they have. And then, you know, really the question of whether to avoid land that's projected to be urbanized or not. And so you could argue that you should jump in and protect the land that should be urbanized, or avoid that conflict and go for the land that has that high quality target habitat that isn't as likely to be surrounded by condos and roads and strip malls and whatever else it might be. And so I think that's an interesting debate, and there are definitely strong views on both sides of that. And that's it. That's it for me.
I just want to say a big thank you to our presenter, Stephanie, today. And thank you all for tuning in. So much, Stephanie. Thank you, Ryan.
Thank you.
Thank you.